Have you ever wondered why the earth quakes, why volcanoes erupt, or why mountains form in the places they do? These are mysteries that have puzzled humanity for centuries. To decode them, we must take a deep dive beneath the Earth's surface, into a world of unseen forces and constant change. Our story begins with the Earth's structure, a complex composition of layers, each with its unique properties. This intricate structure is the stage for a theory that revolutionized our understanding of the Earth's phenomena, the theory of plate tectonics. From the shifting of continents to the formation of mountain ranges, plate tectonics provides a comprehensive framework to make sense of these natural occurrences, but this revolutionary theory wasn't always accepted. Like any great scientific breakthrough, it has evolved over time, shaped by the relentless pursuit of knowledge and understanding. It's time to delve into the fascinating journey of the discovery and evolution of the plate tectonics theory. The theory of plate tectonics, as we know it today, is a relatively recent development in the world of geology. A century ago, the idea of continents drifting across the Earth's surface was considered nothing short of radical. The credit for this revolutionary concept goes to Alfred Wegener, a German meteorologist and geophysicist. In the early 20th century, Wegener proposed that the continents were not static, but rather they moved gradually over geological time. He called this idea continental drift. Wegener's theory, however, was met with skepticism. Critics argued that he couldn't provide a convincing mechanism to explain the movement of continents. Despite the initial resistance, Wegener's idea continued to simmer in scientific circles. Then, in the mid-20th century, everything changed. With the advent of technology capable of mapping the seafloor, scientists discovered something remarkable: seafloor spreading. This was a process where new oceanic crust was being formed at mid-ocean ridges and moved away from those ridges. This was the missing piece of the puzzle that Wegener's theory needed. Seafloor spreading offered a plausible explanation for the movement of continents. It suggested that the Earth's crust was divided into large pieces, or plates, that moved over the semi-fluid asthenosphere beneath them. This idea was the birth of what we now call plate tectonics. The acceptance of plate tectonics theory wasn't a sudden revelation, but a gradual process. As more and more evidence supported the idea, it became clear that Wegener's original concept of continental drift was part of a much larger, more complex picture. Plate tectonics did more than just explain why continents moved. It provided a framework to understand the Earth's major geological processes: earthquakes, volcanic activity, and even the creation of mountain ranges. In the span of a few decades, the theory of plate tectonics went from an idea dismissed by many to a universally accepted explanation of the Earth's dynamic nature. This groundbreaking theory transformed our understanding of the Earth's dynamic interior and its surface features. So what exactly is plate tectonics and how does it work? Well, imagine the Earth like a hard-boiled egg. The shell, thin and rigid, represents the lithosphere, the Earth's outermost layer. This layer isn't one solid piece, though. It's broken into segments called tectonic plates, akin to the cracks on the eggshell. Beneath this hard shell is a softer, semi-fluid layer called the asthenosphere, similar to the egg's white. The lithosphere's tectonic plates float, if you will, on this asthenosphere. Now, these tectonic plates don't just sit idly. No, they're constantly moving, albeit at a pace slower than a snail's crawl. Yet this motion, over millions of years, has dramatic effects. It's responsible for the creation of mountains, the formation of deep ocean trenches, and the occurrence of earthquakes. So fundamentally, plate tectonics is the grand puppeteer of geological events. The motion of these plates shapes the world as we know it. Did you know that not all tectonic plates are created equal? Indeed, the Earth's crust is a mosaic of oceanic and continental plates, each with its unique characteristics and behaviors. Oceanic plates, composed primarily of basalt, are denser but thinner than their continental counterparts. They're like the heavyweight boxers of the tectonic world, sinking beneath the lighter but thicker continental plates at subduction zones. This process, known as subduction, is responsible for some of the most powerful earthquakes and volcanic eruptions we experience. On the other hand, continental plates are made up of a mix of rock types, predominantly granite. They're less dense but significantly thicker, sometimes up to 4 times the thickness of an oceanic plate. When continental plates collide, They form towering mountain ranges like the Himalayas. So whether it's the creation of a new mountain range or an underwater volcano erupting, these tectonic titans are constantly shaping our world. Remember, the next time you feel the ground shake beneath your feet, it's just the Earth's tectonic plates at work.